Alright, so welcome to integral calculus. Whole different animal. Introduction to integration and the concept of signed area. Alright, so first of all, this is the integral symbol. It looks a little bit like the letter S, and there's a reason for that. It comes from the Greek letter sigma, which is all about summation. That's what integration turns out to be in the case of the definite integral. So here are what integrals will tell you. They'll tell you the area under a curve. That's the main thrust of what we're going to talk about today. Notice the quotes around under. We haven't defined under just yet. An integral will tell you what an antiderivative is. If you're asked to accumulate things, you would use an integral. If you're asked about how much change does a function have, that would be about an integral. And summation is about integration as well. So those are the 5 things that this second semester turns out to be about, whether it's the accumulation of population, or the accumulation of velocity, or the accumulation of interest, anything like that, it comes back to integration. Okay, some terms you're going to want to need to know. What I have written on the board there is known as a definite integral. The integrand is simply the function that falls behind the integral. So I would say I'm going to integrate the sine curve. The integral symbol, of course, is the thing that looks like the letter S. The upper and lower limits of integration. The lower limit of integration here is 0. The upper limit of integration is pi. Those are going to be the boundaries that we integrate to. So this question is really asking how much area is there under a sine curve starting at the left edge 0 and the right edge pi. The variable of integration in this case is x. The dx on the end tells me that I'm integrating with respect to the variable x. Note, the answer to a definite integral turns out to be a number. You're asked to solve some definite integral. It turns out to be a number. In this case, that number is 2. So these are some of the terms you can expect me to use as we talk about this throughout the semester. Everybody ready? Okay. Now, if there are no limits of integration, that's known as an indefinite integral. No number at the bottom, no number at the top. The answer to an indefinite integral is going to be some new function. So the first question I had up there said, find the area under a sine curve between 0 and pi. The answer to an indefinite integral is a function. It's asking here for the antiderivative of secant squared. Well, what is the antiderivative of secant squared? Of x, and then there might be a plus 7 or a plus 9 or a plus 12 on the end, and that plus c we take to the end means you can put any number you want out there and it's still going to give you the correct answer. That's known as the constant of integration. What's that? Now, some people will forget to put that plus c in their work and then they'll add it into the end, and then we say that it's the constant of procrastination. Some people will forget them throughout the test, and then at the end of the test they'll go back and add them all in, and we call that the constant of desperation. Okay. Here's the big idea for the day. If you're given a definite integral, what they're asking me to find right here is the area under the curve function f between x coordinates a and b. today it really comes down to being a bunch of geometry questions. No offense taken. So here's an example. Find the integral from -3 to 10 of 5. What shape shows up if you graph y equals 5? A line. Time line. Horizontal line. So this question is asking, find the area under the horizontal line between -3 and +10. So they're really asking for the area of a rectangle. The height of that rectangle is 5. The length of that rectangle is 13. And then you're going to like this. The area of that rectangle is 65. Now you might note that this was created on my calculator. So if you have your calculator so I can show you how to do that. Alright, go to y equals, I think. Go to y equals and simply graph y equals 5. Oops. Now, if you hit the math key, nope, not the math key, second calculate, take a look at choice number 7. It'll give you the integral of f of x. Choice number 7. And then it asks you for a lower limit. In this case, my lower limit was -3. Enter. Then it's going to ask for an upper limit, and the upper limit I had here was 10. Enter. So it tells you that the area of that rectangle, it even gives, I don't know if you've got the same software, but it tells me that mine is from -3 to 10. The area of that rectangle is 65 units. Okay, now there's a second way your calculator can do a definite integral. And it looks like this. You can go to the home screen and you can say Math 9. Now I can type it in directly. A couple minutes ago I put up the problem, find the integral of sine from 0 to pi. 0, pi, and then sine of x. You have to tell it the definite or the derivative is, or the integral is in terms of x. Hit enter, and that value comes up. Now, if you're working on the TI-83 or you don't have the new software, when you do Math 9, the integral symbol doesn't show up. This is what shows up. F-N-I-N-T with an open parenthesis. So here's what you have to tell it. You have to tell it the function first. Then you have to tell it that x is the variable. And then you put in your lower limit, and then you put in your upper limit, close the parentheses, and hit enter. So for the problem I just did, it would be F-N-I-N-T. I would tell it I'm integrating sine of x, comma, x is the variable, comma, from 0, comma, to pi, close the parentheses, hit enter, and it'll show me a 2. Now, if you have your function entered as y1, then you can put y1 here instead. So you can do definite integrals on your calculator either at the graph using second calculate choice number 7 or at the home screen using Math 9. All right, so that's how you're going to check your work today. Let's take a look at a few more problems. Find the definite integral of the line y equals x from 2 to 10. What shape are we talking about here? Close. Is it? Trapezoid. If it was from 0 to 10, it would be a triangle. But from 2 to 10, we're talking about a trapezoid. So there's the line y equals x, and I would have limits at 2 and 10. So that question is asking me for the area of the specific trapezoid. How long is this line? 8. How long are the two bases? 2 and 10. So the area would be 1/2 of 2 plus 10 multiplied by 8. 48. And the integral from negative 10 to 10 of the square root of 100 minus x squared. What shape are we dealing with? Semicircle with radius 10. Find the area of a circle with radius 10. 105. Cut that in half. 55. All right, let me change the question ever so slightly. Find the integral from 0 to 10. Quarter of a circle, isn't it? 25 pi. All right, now let's really improve this question. Find the integral from 0 to 10 of the square root of 100 minus x squared plus 20. What does this plus 20 do to the graph? It's a vertical shift by 20 units. So now my area is not only the original quarter circle, but also the rectangular area underneath it. How much area was there in that quarter circle? 25 pi. And then the rectangle underneath it would be height 20, length 10, or 200. Can't see it here. If you check that on your calculator, it turns out to be 278.53985, which is in fact 200 plus 25. Yeah?
Tess, are you going to be asking us for the exact number or pi?
I'm going to be asking you for the exact number in some instances, and other cases you'll have to use your calculator. On the first test, it'll be exact values. It's a little tougher. Integral from 3 to 10. What shape am I talking about? What is it? The line y equals x plus 5. Now that line has a little hole in it, doesn't it? It's got a hole in it at 5. Is that going to affect anything? How wide is that hole? It's infinitely small. So I'm not going to lose any area underneath it. So this really turns out to be the integral from 3 to 10 of x plus 5. What shape am I talking about? The trapezoid. There's the line y equals x plus 5. If I start here at 3 and I work my way out to 10, how long is that base? 7 units. Actually, that's the height, isn't it? How long is the base? Keeping in mind this is 3. This length would be 8, because this would be the point 3/8. And the other base has a length of 15. So the area would be 1/2 of 8 plus 15 times 7. And heck, I don't even have to simplify that. That's correct. The whole doesn't make any difference. Integral from negative 5 to 10 of the absolute value of x. What is it? 2 triangles. Look like that. How long are those two segments going to be? This is negative 5. This length is 5, and this length is 5. If I go all the way out to positive 10, this would be 10 and 10, wouldn't it? So the area of the first triangle is 1/2 of 5 squared, and And the area of the second triangle is 1/2 of 10 squared. Some number. Okay. Punch this into your calculator right now. Integral from -6 to 0 of x. So that's a new one for you. That's the first time in all the area questions you've ever answered that the answer was negative and correct. Now, a while ago we talked about integral means area under a curve. But I said we still kind of need to define the word under. The area under a curve is the area below the curve above the x-axis. So this area that you just found actually turns out to be quite the opposite of that. It's the area above the curve below the axis. And when you calculate an area that's above a curve but below the axis, it will be assigned a negative value. An area is above a curve and below the axis, it will be assigned a negative value. Now, for the purposes of stuff we're going to talk about later, if you see the word between, if they ask you for the area between curves, that will always be positive, no matter what. But area under a curve can be negative. And if they ask for area between curves, you have to see the word between, whereas area under a curve is just implied by the integral. So if you see an integral symbol, they're not asking you about area between curves. The word between actually has to be there. Okay, try this. Integral from 0 to 12 of x. 72. Now we're just talking about the triangle whose length is 12 and whose height is 12, right? So without a calculator, I want you to tell me the following. The integral from -6 to 12. Pardon me?
36.
How'd you get 36?
Half of 72.
Nope. What is it? Let's backtrack for just a minute. The integral from -6 to 0 was -18. And now, the next thing we said was that the integral from 0 to 12 is 72. My question is, tell me the integral from -6 to 12 of x. We said this first triangle had area -18, and the second triangle had area +72. And the accumulated total area then turns out to be 54. Alyssa.
So I was messing around with my calculator. I did x cubed, and then I did from -4 to 4.
Should be 0.
Yeah. So it should be 0.
Yeah, because you know how we spent all that time last year studying odd and even functions? Well, the reason we spent all that time studying odd and even functions is because when you integrate an odd function which has origin symmetry, if your left and right limits are opposite numbers, you can always easily recognize that to be 0. So if you were to integrate x cubed from, say, -10 to 10, the positive area on the right and the negative area on the left turn out to be the same number, and you get 0. So it's really nice in the study of integration if you can recognize when a function is odd, because a lot of times you can just zero out the area. Even functions are nice because you can work with 0 as a limit of integration. Say I wanted to integrate x squared plus 4 from -10 to +10. I could simply integrate it from 0 to 10 and double based on the y-axis. That's why we spend our time in pre-calculus studying those two concepts, because they really help you in visualizing integrals. Okay, so let's back up. When calculating the area under a curve, area that is above the curve but below the axis will be assigned a negative value. Later, you'll be asked to find the area between a curve and the x-axis. In that case, all numerical areas have to be treated as positive. So, I could change the question. If you go back here for a minute, this problem was written as a definite integral. But if I said, find the area between the line y equals x and the x-axis on the interval from negative 6 to positive 12, then the answer actually would have been 90. Because if the word between is there, then all regions have positive values. The sign being negative essentially means that the area is below the axis and above the curve. It tells you more about location. The 18 is still the size of the region. The negative tells me where it's at. And the fact that this one was positive 54 just tells me that most of the region is above the axis, even though some of the region is below the axis. Okay. The integral from 0 to pi over 2 of the sine of x is 1. That's a fact you simply need to know. Tell me about the integral from pi over 2 of cosine of x. Didn't we just say that a sine curve or a cosine curve is a sine wave shifted over? I'm not ready to give you the assignment yet. Find the integral from 0 to pi of a sine wave. Do that on your phone. What happens if you go from 0 to pi? You get 2. And you go from 0 to pi, the sine of x turns out to be 2. Now go from 0 to 3 pi over 2. How did you get back to 1? And that third region has a negative value assigned to it, correct? How about then if you went 0 to 2 pi? That would end up being 0. What happens if you go from pi to 2 pi? Pi to 2 pi would be negative 2. What if you went from pi over 2 to 3 pi over 2? 0. So the little arches underneath the sine wave have an area of 2 units. Each quadrant has a value of 1. Now let me add one last thing here. Give me your best guess. Integral from 0 to pi of the sine of x. Tell me again what that is. That's 2. What if there was a 5 right here? You think it's 10? Yeah. It is. What's your logic behind that?
Because it's a constant, so I just assume you can pull it out.
It's a constant, so you can pull it out. That's a pretty good assumption. We had a constant multiple rule for limits when we studied limits. Then we had a constant multiple rule for derivatives when we studied derivatives. And yes, there is in fact a constant multiple rule for integrals, which says this 5 can in fact be moved out here. And if you think about it, this thing in parentheses is just a really unique way of writing the number 2. So this does in fact turn out to be 5 times 2. 10. Okay, so that's enough. The handout I'm going to give you is fun and interesting.